we are starting the new topic, that is the capacitor. These are the symbols you will see in some circuits, and just below symbols, fixed capacitor, polarized capacitor, variable capacitor, these are the symbols you will use in the numerical. Now, capacitor definition you should know: two conducting plate separated by insulator or dielectric or air, that is known as the capacitor. And right hand side we have drawn the symbol. The difference in the capacitor symbol and battery symbol is that if you draw the battery symbol, the symbol should be, just a minute, I think there is software problem again. This is a symbol for the battery cell and this is a symbol for capacitor. Now first question is that, is there exists a maximum capacity up to which the body can be charged? Listen, suppose I say this is a random shape body of irregular fashion. You give any charge to body. We all know charge will distribute in such a way that sigma is proportional to 1 by r, that we people have discussed. It means if there is a sharp zone, charge density is more because sigma is proportional to 1 by r. Now if you increase the charge to this body, we all know sigma will increase because sigma is charge density. And if sigma is increased, we all know electric field just outside the metal is given by E equal to sigma by epsilon naught. It means if E is increasing, sigma is increasing, electric field will also increase. And we all know electric field is always perpendicular to the surface, like this. Similarly everywhere. Now this charge body is in contact with the surrounding medium, and medium is having the dielectric molecules. So due to this electric field, firstly there will be polarization in the dielectric molecule. Stressing, we know positive move along the direction of the field, negative opposite to the field, like this. And it will happen everywhere surrounding the medium, surrounding this charge body. Now if I increase the electric field, why electric field is increasing? Because we are increasing the charge. Again listen, we increase the charge density increases, electric field increases, polarization increases. Then a situation may come that this positive and negative may separated, that we have discussed. It is known as the dielectric breakdown. Now this negative may neutralize this positive because electron can move. So ultimately what is happening, you are giving the charge and charge is leaking to the surrounding. So we say there is a maximum capacity up to which the body can be charged. Read this slide. And this maximum capacity depends on the shape of the conductor, because we know if there is sharp end, charge will leak fastly. If it's spherical body, you can give more charge, and also it depends on the dielectric strength of the surrounding medium. So just read it. Now, can capacity of a conductor be infinite? So you just realize one situation. If I say there is a glass like this is a glass, and this is a capacity to fill up to the brim level, and suppose I say here capacity is 10,000 liter, suppose. Now if you insert more water from outside, all of you know that water will leak out. It means every container has some capacity. So is there any capacity of the conductor to be charged up to infinite? No. Again listen the last slide which I have discussed. Suppose I say this is a spherical body, and I say here charge capacity is 10,000 coulomb. Exactly same phenomena I am relating. And suppose I say when charge is 10,000 coulomb and voltage is also 10,000. Suppose both are same. We are just taking the situation. Now by chance we add plus 1 coulomb charge more here on this body, already 10,000 coulomb charge is there. Now you are adding plus 1 coulomb charge. So what is the total charge now on the body? 10,001 coulomb. I hope it is clear to all of you. Now what will happen? As this charge increases more than 10,000 coulomb, we all know very well potential is also increasing, because kq by r, it should be 10,001 volt. And when potential increases, electric field also increases surrounding that we have discussed in the last slide. Now what will happen? Due to this high electric field, there will be polarization in the air molecule. Positive will move along the direction of the field, this is the field direction, and negative move opposite direction of the field. So as you give plus 1 coulomb more charge, this positive charge attract the electron from the surrounding and neutralize. Ultimately again charge becomes to 10,000 coulomb and voltage again becomes 10,000 coulomb. Sorry, 10,000 volt. It means always there is a limit up to which the body can be charged. Now suppose surrounding medium I am changing. In place of air I say surrounding there is mica sheet. You will read in detail in dielectric also. And we all know dielectric breakdown the mica is more compared to the air. It means if dielectric breakdown is more, you can give more charge to this metal body compared to the air surrounding. Similarly, if this spherical ball is placed in vacuum by chance, it is placed in vacuum, then all of you know capacity will be infinite, because there is vacuum, no dielectric, so no dielectric breakdown, you can give any amount of charge. So if a conductor is placed in vacuum, then we will think its capacity is infinite. Its capacity is infinite. Why infinite? Clear? Because there is no surrounding medium, no dielectric there, no dielectric breakdown situation, so we can give infinite charge. So if there is a conductor placed in vacuum, then its capacity is infinite. Okay. Capacitor I have discussed earlier, again I am discussing the definition, that two conducting plates separated by a certain distance form the capacitor, and between the plates there may be air, and like you said these are the two plates, between there is air capacitor, between there is dielectric capacitor. Now this is very important line. It is a very common misconception that a capacitor stores charge, but actually stores electric energy in the electrostatic field between the plates. Because whenever I ask you people what is capacitor, you speak capacitor is a device which stores charge. That is wrong. You have to say capacitor stores electric energy in the electrostatic field between the plates. Now capacitance, again I am discussing this point. As we have discussed in the last slide, if you increase the charge, voltage is increasing. So Q is proportional to V, and Q equal to CV. This C is known as the capacitance. Now you can easily define capacitance. I have no need to explain it. Capacitance is the property of the system of conductors which show ability to store the electric energy in the form of electric field around it. And you say Q is proportional to V, Q equal to CV, C is the capacitance, and this is simple definition. Capacitance is defined as the amount of charge in coulombs necessary to increase the potential of a conductor or potential difference between two conductors by 1 volt. Now SI unit of capacitance. So SI unit is known as farad, and if CGS unit is asked, you will say state farad, because I told you whenever we have to discuss CGS unit of current, state ampere, CGS unit of charge, state coulomb, like this. And how to define 1 farad? I think you know the formula, Q equal to CV, C equal to Q by V. So 1 farad equal to 1 coulomb upon 1 volt. Now I have written the definition. Okay, relation between SI and CGS unit. I think you can do your own. I just give you the formula Q equal to CV. Now if CGS system, Q is ESU or state coulomb, capacitance state farad, voltage state volt, and SI system need not to explain, you please derive yourself. This is the result. Now, is farad a very big unit of capacitance? In real life, can we have easily the 1 farad capacitance? Listen students, later on I will discuss the spherical body capacitance that is given by C equal to 4 pi epsilon naught R. Now C is known to you, suppose you say it is 1 farad. 4 is known to you, pi is known to you, epsilon naught we have discussed a lot. If you calculate the R, size of the sphere, that will be very large. That is 9 into 10 raised to the power 9 meter. So it is very 1 farad is a very big unit. So we can say if we want the 1 farad capacitor, we require the conducting sphere of radius 9 into 10 raised to the power 9 meter. So it is not feasible. Now factors on which capacitance depends. I will show in the animation also, but you should know it. Capacitance basically depends on the area of the plates. Capacitance depends on distance between the plates, and capacitance depends medium between the plates. Area means overlapping area of the plates. If I say suppose these are two plates having each of area A, and these are two plates each of area A, then you have to count only overlapping area. Of course we will discuss in detail. And similarly, if you decrease the distance between the plates, capacitance will increase. And if you increase the dielectric medium between the strength of the, suppose you say you put some dielectric material between the plate and you increase the K, later on you will say capacitance will also increase. So at present I am showing you one animation. You just please go through that animation.
Charged particles are fixed in place, whereas the negatively charged particles, called electrons, are free to move around. A metal typically has an equal amount of positively and negatively charged particles, making the metal as a whole electrically neutral. If we apply a force trying to push extra electrons into this metal plate, we will not be successful, because particles with the same charge repel one another. If extra electrons accumulate inside the metal plate, they will repel each other and repel any of the new electrons trying to enter. Therefore, even if we apply a force, the metal will remain electrically neutral. Now let us consider a new scenario where there is another metal plate close to the one shown. As electrons accumulate in the first metal plate, they will repel the electrons in the second metal plate. The positively charged particles left behind in the second plate will exert an attractive force on the negatively charged particles in the first metal plate. This makes it possible for the first plate to have more negative particles than positive particles. As we add electrons to the first metal plate, an equal number of electrons leave the second metal plate. After a certain number of extra electrons accumulate on the first plate, they will repel any new electrons trying to enter. The first metal plate has developed a net negative charge, and the second metal plate has developed an equal and opposite net positive charge. We can cause this equal and opposite charge on each plate to be larger by applying a larger external force. If we remove the external force we are applying, the extra electrons in the first metal plate will continue to repel one another. We have now returned to our original condition where the net charge on each plate is 0. The two metal plates are what we call a capacitor. Note, voltage is shown upside down in this video because the blue arrows will show electron flow. By briefly connecting the capacitor to a battery as shown, the two plates have developed equal and opposite charges. If we then connect the capacitor across the light bulb, all the extra electrons in the negatively charged plate will move to the positively charged plate through the light bulb. If we use multiple batteries in series, then we can force the two plates of the capacitor to develop larger amounts of charge. When the capacitor is charged, its voltage will be the sum of the voltages of all the batteries. Charging the capacitor to a higher voltage will cause the light bulb to stay on longer when the capacitor discharges. Now suppose that we increase the areas of the two metal plates. This increased area allows us to push more extra electrons into the first metal plate and remove more electrons from the second metal plate without applying a larger external force. When a larger capacitor is connected to our battery, it'll take longer for the capacitor to charge to the voltage of the battery. Although the final voltage is still equal to the voltage of the battery, for a larger capacitor, this voltage represents a larger amount of charge on the two metal plates. The larger capacitor will take longer to discharge through the light bulb, thereby allowing the light bulb to stay on longer.
This charging and discharging we will also discuss mathematically, so that formula is also very important.
Suppose that we add a special material in between the two plates.
This material is dielectric material.
This material does not allow any particles to flow through it, but it contains molecules that change their orientation based on the charges of the two plates. These molecules exert forces that attract more electrons to the negative plate and that repel more electrons from the positive plate. The presence of this material has the exact same effect as does increasing the areas of the two metal plates. This allows the two plates to develop larger net charges for the same amount of applied voltage. We say that we've increased the capacitance of the capacitor. There is also a third way to increase the capacitance of a capacitor. This is by moving the two metal plates closer together. Because the two plates are now closer together, they exert greater forces on each other's electrons. This attracts more electrons to the negative plate and repels more electrons from the positive plate, allowing the two plates to develop larger net charges for the same amount of applied voltage. This has the same effect as inserting the special material and as increasing the areas of the metal plates. To create the largest capacitance possible, we want to make the areas of the plates as large as possible, insert the special material in between the plates, and move the two plates as close together as possible. The larger the capacitance, the more energy will be stored for the same amount of voltage.
So now I hope that it is clear to all of you. Capacitance depends on the area of the plates. Generally we will say overlapping area, and capacitance inversely proportional distance between the plates, and capacitance depends on medium between the plates.